Hello everyone, and welcome to this Ask AuxEn Anything session, episode number 5. And as you all know by now, that this is an online platform where we try and answer to the queries that are posed by uh, structural civil engineers, and those queries are usually related to the difficulties or doubts that they are facing related to a particular project or any difficulty regarding the RCC steel design or any construction and or site issues. So usually these are the queries that we handle during these live sessions, and this is the fifth such episode. So we'll straight away go into the queries and let's take them one by one. So first of all, we'll be taking the queries that have been posted on this Google form. So that are the queries that I would like to take first. There was this question that was asked in the last session by Narayan Muduli from Odisha. He had asked, can you easily explain the sign convention for moments in plates and shell elements? So you can refer to an online series that we used to do on YouTube earlier by the name of Project Discussion Series. So you go to the episode 6 of that series, and there you will find that we had taken up this issue and we had discussed over there in detail. So you can refer to the episode number 6 of Project Discussion Series. Okay. All right. So let us take the first question. This is by Mr. Tosh Agrawal. He is joining us from Raipur and he is a working professional. So let me just take his question first and let's begin by answering to his question. Okay. So, yeah, let's see what I can do. So today the questions on Google Form are less. So maybe if you want to ask, you can also put your questions in the comments. So once the queries in the Google Form are done, then we will go to the queries in the comments of YouTube live comments. Okay. So you can just put in your queries over there also. So he's asking about jack beam, and before I answer his question, I'll just open that reference handbook so that it can be better explained that what is jack beam. Just give me a minute. I'll just open one figure for better explanation. So where do I go? Jack beam. There is this very good figure in the steel handbook that we were talking about in one of the earlier sessions also. So just let me try to find out that figure first. Uh, just hold on while I'm searching for that figure. This one. Yeah. Okay. So what is his question? His question is when to provide jack beam and how should be rafter and jack beam connected. Okay. So when to provide, the answer is it will depend on the structural or any other requirement. What do you think? If anyone in the live audience can tell me, why do you think jack beams are usually required? So this is what is called as a jack beam. These topics we have discussed in a lot of detail in our PEB course. So this is a jack beam. Okay. So why this jack beam is required? Because jack beam means which does not have a column supporting it below. That is what we usually mean by jack beam. So why do I provide a jack beam? Because let's say I want a larger column spacing over here. So if a larger column spacing is required, we usually like to go for a jack beam arrangement. So instead of taking a column over here, what I'm doing, I'm supporting this jack beam on a beam over here, on a normal, you could say, on a normal beam over here, which in turn is connected to these two columns. So now what is this question? When to provide? So when to provide? When we require larger column spacing, if that is your desire, and that larger column spacing is required at few locations, then we can provide this type of a jack beam arrangement. What is his second question? How should be rafter and jack beam connection made? Moment connection or simply supported connection? No, how should the rafter and jack beam connection made? Okay, so see, about the choice of connection, it will depend on the structural designer and it will depend on other configurations. Usually, this connection over here, he is asking. So first, he is asking the connection between jack beam and rafter. So this is my jack beam and this is the rafter. So his first question is, how is this connection being made? So it again depends on the designer. You could make a simply supported connection over here. You could make a simply supported connection over here. But if you decide to make a simply supported connection, remember that for lateral loads, you will require some additional arrangement like elevation bracings. Now that may not be possible to provide elevation bracings over here, maybe at this location. So you may provide elevation bracing in the other bay just to stabilize the system, or you may provide a moment connection over here, rigid connection over here. Okay, so it will depend on the designer as to what type of connection they are wanting to make. Whatever decision they take, the other things like detailing and other design aspects will have to follow this decision. Which decision, which connection type to provide. His second question is, how will the rafter and jack beam connection? So this is my rafter. Oh, sorry. This is my column, not rafter. Sorry, this is column. My mistake. I wrote it rafter. So jack beam column connection. Quick answer again. It will depend whether you want to provide a simply supported connection or a rigid connection. Usually, we would like to provide a rigid connection because otherwise lateral resistance along the length of this shed will become problematic in this area. So it will be better if I can provide a rigid connection over here, jack beam to column. His second question was rafter to jack beam. So this is my rafter and this is the jack beam. Again, if you provide a simply supported connection over here, what will happen? The sagging moments at the midspan will increase. If the sagging moment at midspan increase, then naturally you may provide larger sections. So that would mean that this rafter section, which is at jack beam location, will be of a different section than this rafter section, which is over the two columns. Okay, that is if you have decided to go for a simply supported connection over here. So because your usual rafter column connections are rigid connections, so they have a section size according to that. Now if you decide to provide a simply supported connection over here, then your rafter sizes may change, and every rafter which is provided over jack beam, it may have a different size. Now if you choose to provide a rigid connection over here also between the rafter and the jack beam, then that is a better scenario, I would say. So if you provide a rigid connection over here between the jack beam and the rafter, sorry, between the rafter, why am I mixing out names? Between the rafter and jack beam, if you provide a rigid connection over here, that is advisable. But then what will be the problem? What will be the problem if I provide a rigid connection between this rafter and jack beam? The design issue will be that this jack beam then will come under torsion, isn't it? Jack beam under torsion. So you will have to accordingly ensure that jack beam is designed for that torsion. Now, interestingly, IS 800 2007 does not give you any check, any provision, any codal line related to torsion design of structural steel members. I don't know if you are aware or not. IS 800 2007 does not give you any process to be followed in case you have torsion in your cross section. So then you will have to go to a code like AISC American code, and you will have to design this jack beam for the torsion that will come from this rafter. Okay, so the decision again between the connection type between rafter and jack beam will depend on the structural designer. Whatever decision you take, accordingly you will have to ensure that other things are done. Okay, right. So this was his question. Moving ahead, next question is by Mr. Ashwin Kumar. He is joining us from Karaikudi. He is a working professional. He is asking how to calculate dead loads of purlins and guts. So dead load, I mean, dead load is simple. Dead load is just the self weight. Dead load of the purlin and gut is nothing but the self weight of purlin and gut. So is there any specific? Mr. Ashwin, is there any specific? Because I can see you live on this thing over here. Is there any specific query related to dead load calculation? How to calculate dead load of purlins and guts? That is his query. So I guess the answer is it looks simple that for this you can you may assume some section to begin with. Okay, if you have not finalized the design, most of people by experience know that what sort of section for purlin and guts they may require. For example, for normal wind load cases, up to a span of 7.5 meters, maybe a Z section, a Z purlin of uh, maybe around 2 mm thickness, sorry, 2 mm thickness, and this around 200 mm, and this being around 50 mm, this being around 15 mm, and this is 2 mm. Just hold on, give me a minute. So this type of a section is usually sufficient. Okay, just hold on, I'll be back. Yeah, so I was telling that a 200 mm section for around 7.5 meter span, 200 mm deep, and having a thickness of around 2 mm or even 1.8 mm. This type of section may be good enough for a 7.5 meter span, maybe with two sag rods. So if you know this section, you can easily calculate its sulfate, isn't it? What will be its sulfate? So you just add up all these dimensions. You will get the total sort of running length of this cross sectional member, and this you multiply by the thickness 2 mm. This entire thing you multiply it by 7850 kg per meter cube. Of course, make the units consistent. So you will get the dead load of purlins and guts in per meter units. So I mean that is simple. So I don't know what exactly you want to ask, how to calculate dead load of purlins and guts. So this is how you calculate. Or if you are using any other section, for example, you are using some channel section up to 6 meter span or 5 meter span, or you are making some built up purlins for larger spans. For example, the type of sections you see, uh, the type of sections you see in railway stations, okay, the built up purlins. So whatever section you have decided, according to that, you can calculate the dead load in per meter. I think that was what you were asking. And to this, you can add the sheeting weight. So sheeting weight, it will depend on what type of sheeting you are using. Okay, usually it will be around 3.5 to 4 kgs per square meter sheeting weight. If you have some insulation, then you need to add the weight of insulation also. So in this manner, you can just add up all the weights, and then finally you can calculate it in per meter units, and then apply it on purlins or girts, or if you want to apply it on rafter, then you can apply it on rafter also after proper calculation. So I'm not sure if this was what you were asking, uh, but I think if you are asking about the dead load, this is how you need to do it. Okay. All right. Then we go to next question. Mr. Saif Ahmed is saying we can get it from manufacturer also. Yeah, of course, but then again you need to know, or you need to sort of decide what section you are going to provide, isn't it? So first you need to know that this section or this particular section I'm going to provide. Of course, that cannot come before you do the analysis and design calculations. But after doing a lot of work, you will get a sense that for this much span, for this much type of wind load, this sort of purlin or this type of girt shall be sufficient. So you need to assume some section to begin with. Okay, I hope you got it. Yeah. Next question is from Mr. Tosh Agrawal. He's joining from Raipur and he's a working professional. So he has a good question that we should discuss, because this is a doubt that is often not just his doubt, but this is often a doubt of many engineers, especially related to trusses, because in trusses there's a lot of jugaad work that we do usually. So what is his question? I'll just first share my screen and then we will discuss. So let's see what he's asking. Right. So his question is, when we have a normal column cap. Okay, so first I'll read his question, then I will try to explain what he is trying to say, and then we will answer his question. Okay. So he's saying when we have normal column cap at either ends of truss and steel column, and we release movement at truss ends, then will the column act as hinge support for for I don't think it does, as or the column will allow certain displacement in lateral direction, putting bottom chord in tension, which basically means we don't need roller in truss with less stiff column. Okay, so I think he's saying what he's trying to say. We'll try and understand it by a sketch. So suppose this is my column, okay, whatever steel column it was. Don't worry about the steel cross section. Just assume that this is a column right now, okay, and then this is my another column, and now here I have a truss. Now usually this type of a truss, most of us, what we do is that when we do our normal study, then we assign or assume this truss to be a pin roller type of arrangement, isn't it? Why so? Because that is how the truss can be most easily analyzed and understood. That's why we assume one end to be hinged, one end to be roller. Okay. So this makes our life quite simple, and we are able to analyze it through easy hand calculations also. the structure becomes determinate and life's easy for us. But in actual practice, it is very difficult to make these types of hinge and roller assemblies on site. Okay, so then what do? We do all sorts of jugaad work. And what are all those jugaad works? So we will try and make some connection over here, which is not going to be very rigid. It will only take care of the thrust from one side. Okay, it will not be very rigidly connected, so it will allow moment rotation. On the other side, because we want to create a roller like assembly, what do we do usually? I'm showing you in plan over here. So if this was my base plate, okay, and let's say this was my truss member, so I will have two base plates. One will be connected to the bottom of this bottom cord, and the other will be connected to the top of the column. So one plate is connected to the bottom of bottom cord, and the other plate is top of the column. So situation is like this, that I have this plate, okay, and then I have another plate just below it. I'm deliberately making it little bigger in size so that it is identifiable. Usually it is the same size as of the upper plate. Now what we do is we will make slotted holes over here. So our hole will be like this, slotted hole. Is it clear? Now what this slotted hole does is, so this slotted hole will be made in the upper plate, and the bolt will be like this, which is connected to the bottom plate. Okay. So what is happening, that when this truss, because we wanted to have a roller like assembly, we have provided this type of situation, slotted hole arrangement. So in this slotted hole, what we are doing basically, that any lateral thrust, if this truss wants to move because of this lateral thrust, and because we are assuming it as roller, there will be enough there will be enough pathway provided to this plate so as to move it in the lateral direction. Okay, understood? So this is called as a slotted hole assembly. Now this is a jugaad work. It is not a foolproof sort of thing that we do, but this slotted hole type of assembly is quite common if you see it in trusses. Okay, so this helps us in our assumption that one end is hinge, other end is roller. And then if you refer the last episode of this Ask AuxEn Anything, I had explained that now if this is roller, basically what you are saying, that this column is sort of a cantilever till a certain moment, or till a certain lateral translation, isn't it? Do you understand? Till a certain amount of lateral translation, this column is a cantilever right now. Maybe beyond that, it becomes propped cantilever when the uh, when, let's say, this green plate reaches to the end of the slotted hole. Then sort of you can say that it becomes a propped cantilever. But till that time, this column is a cantilever. And then how do you support this? So I had explained that you may provide some in-plan bracings. Usually these bracings are connected to the bottom cord and a member which is called as a tie runner. So these discussions we had in the last session. But now what he is asking, that when we have column cap at either ends. Okay. Okay. So now if you don't provide this slotted hole, what, and if I sort of provide hinge assemblies on both ends. Okay. So this was my truss, and I am providing a hinge assembly on both ends. Now what is the problem with these types of things? That there will be a, because it's a hinge assembly, this truss will try to deform, and there will be a axial thrust created. There will be a axial thrust created. So this axial thrust, what happens because of this axial thrust, this column will now have to take this axial thrust, and it will transfer, or this column will have to resist the bending moment generated due to this axial thrust. Okay, so that is the issue that arises out of this sort of a configuration. So usually if we want to save our column from this moment that is created due to axial thrust, we usually uh, sort of avoid providing a hinge assembly. Okay, so now what he is asking, so this was basically the explanation before we answer his question. Now let us read his question and try to answer it. Just give me a minute before that. Yeah, so what happens now? Mr. Tosh is saying, will the thrust be in both directions? Yes, because see, this basically what will happen. This thrust will try to bend down. When this thrust tries to bend down, it will try to open up. Now this opening up, because it will be resisted by the pin support, it will generate thrust on both sides. Okay, so when this thrust is generated on both sides, then there will be a moment that is generated in the column. All right, so his question now is, what is his question? Then we will the column act as hinge support? For I don't think it doesn't have lateral stiffness more than axial stiffness, or the column will allow certain displacement, which basically means that we don't need a roller in truss with less stiff column. So I don't know what he's asking, or the column will allow certain displacement. I'm not sure what he's saying. I guess you got the answer. The effect is that if it's a hinge connection, something has to take this lateral thrust that gets generated at the ends. Okay, and this lateral thrust, of course it will be also be resisted by bottom chord, but then these columns will also have to take that lateral thrust effect. Okay, Mr. Toshi is saying axial stiffness of bottom chord is more. Yeah, so yes, so bottom chord will be in tension. I think I have only explained the his question. I have not explained his. I mean, we have still not provided answer. I think I have only explained what he is trying to ask. But that is what I understood from his question. When we have normal column and we release moment at truss end, then will the column act as in support? I'm not sure if I have been able to answer. Ajay, he has understood. Very good. That is good. He has understood. Okay, nice. Because I was not able to fully understand his question, but I just explained the system that is usually adopted. Okay, anyway, so it is good that he understood. So then I think we can move to next question that was posted. So this question is by is from Mr. Ramarjun. So he is joining us from Bahrain. He is a working professional and he has asked a few questions. So maybe I'll just copy and paste uh, paste the question and then answer them. Okay, right. So let us see what his questions are. So as per Indian and international standard, expansion joint maximum and minimum distance for building and boundary wall. How the fix in concrete and steel building, type of material, pictures, details. Please explain. No, so expansion joint usually, if I remember correctly in codes, usually they will say 30 to 45 meters. You should provide an expansion joint. This is if I remember correctly. Okay. Uh, as per international, how to fix in concrete and steel building. So expansion joints usually, I mean, expansion joint means an expansion joint. So there will be a physical gap between two objects. That is what is meant by expansion joint. And how do you calculate this? So as per the thermal movement, you will calculate this expansion joint gap. Okay. The type of material. So once you leave this gap, then you fill it up, because otherwise if you leave a very large gap, this space may not remain serviceable. So you will have to leave this gap over here, and then because you want to have it serviceable also, you will fill it up with some non-shrink compound. Some people fill some silicon based product over here, or any other non-shrink compound that you wish to fill over here, that you may fill, or any rubber or elastomeric compound is also filled by people. So that is what they do. I am not very sure about the code which deals with this filling in the expansion joints. Uh, for the steel building, existing concrete column and beam proposed, steel beam connected like monoslope truss. How to connect? Because the beam connecting not straight, it has slope 4 degrees. Connection plate if directly connected to the beam, or we provide pin plate. No, I am not able to understand what he's asking. For the steel building, existing concrete column and beam proposed. Steel beam connected like monoslope truss. How to connect? Because the beam connecting not straight. It has slope 4 degrees. Connection plate if directly. No. Please provide some images. Question not understood. In steel structure, kindly explain compact and semi-compact. See, this compact semi-compact is the classification which is based on the local buckling effects which your cross section may undergo uh, under the effect of any compression. That compression may be generated due to axial compression or bending compression. So depending on that, you have got the section classifications: plastic, compact, semi-compact, slender. In Indian context, there is a table 2, I think, which deals with this section classification. In our course on steel design, we have covered this issue in great detail, which you have also joined. So his question is, so in the course we have very well explained what is the meaning of compact, semi-compact, and how to do all these classifications. And then his question is example beam. Okay, so he's asking whether our beams we should take compact, semi-compact. What should we take? General strategy followed by people is mainly in the PEB industry. The general strategy that they follow is that flanges, and I'm saying this is the general strategy. Flanges they take semi-compact usually. Okay, and webs usually they design it as, or generally the webs are slender. So this is the usual strategy that is followed by the PB people who are doing pre-engineered sheds. or people who are using such systems, that is the usual strategy that they follow. That for sections they have a semi-compact flange and slender webs. Okay, so it all depends on what sort of economy you can achieve, and that's how they decide. If you have a compact section, you are allowed to take ZP for your bending moment capacity calculation. If you have a semi-compact section, you have to take ZE. So this ZP to ZE in I sections, there is a uh, magnitude difference of around 10-11%. Okay. So if you are using a semi-compact section, you are reducing the capacity of your section by around 10-12%. But then it is also saving you on costing. So they might increase the web depth to take care for that extra 10-12% lost, and they try to arrange their section accordingly, which is the most optimized section. So usually what I have seen is that they try to go for a semi-compact flange and slender web. This is, I'm only talking about the sections that are usually used in these industrial sheds, pre-engineered industrial sheds. Okay. Okay. Then his next question is, what is the maximum length? What is the maximum length of block or brick wall constructed by any support like column, and maximum height without lintel? So, see, maximum height, it will usually depend on what sort of loads your brick wall has to take. Now, most of the time, you will say that it is only a partition wall, so it does not have to take any load. But still, there are some slenderness limits also for the brick wall. And if you have a mid to high rise building, then that brick wall also has to take lateral loads in the form of wind. That brick wall also may have to take some lateral load due to any seismic effect because of the self-weight of the brick wall. So in such cases, there are some guidelines given about the ratios to be followed for the brick wall height to its thickness. So there is an Indian standard for structural use of brick wall. So although your brick wall may be part of your partition wall, but still you can refer to that code. Uh, the number I'm forgetting, but it is about the structural use of masonry. Okay, if you search it on the internet, you will easily find it. I'm not able to remember its name right now. Uh, but it gives you good explanation. There are some good figures given about the slenderness ratio that you can have for your brick wall, about the thickness that you need to maintain for your brick wall for a given height. So all those things are given in that code. Uh, you may try to search for it, and you will get a good idea. So from that you can calculate that till what height you can have a brick wall without providing a horizontal tie or without providing vertical columns. Okay, so that code will give you good idea about that. I'm not able to recall its number right now. Mr. Tosh is saying bottom chord will take tension. Bottom chord, as I explained, if it was free, if it was hinge and roller, it would take tension. But now, right now, it is trying to, uh, it is sort of trying to take tension, wanting to take tension, but because it is constrained by the axial thrust, so there will be some compression that gets generated as a reaction from this axial thrust. So you will see a non-uniform distribution, and there will be larger compressions over here, so that axial thrust will balance out the tension in the bottom chord. What I'll suggest is you can make a quick model in STAD or ETABS, whatever. Try to provide hinge connections and see what is happening with the output. Okay, then you will understand what I'm trying to explain. Okay, very good. So uh, now we move to next question that was asked. So next question is asked by Mr. Saif Mohammad Saif Ahmed Chaudhary. He is joining us from Guwahati and he is a working professional over there. So his question is, can you please throw some light on flat slab without openings for commercial buildings as it is very critical in punching? What reinforcement detailing should be adopted at those areas? Can you please explain about it? What steps we can make it safe at critical junctions? So, okay, let us try and answer. So I'll just share my screen. So have you done any, has any one of you in the live audience, those who are over here, have you designed flat slabs with punching reinforcement? So if I have a flat slab and let's say I have a drop, you all understand about punching reinforcement? Okay. Yes. Has anyone done it? So uh, usually we provide drops below our flat slab because, as you are aware, punching is a critical issue. So we provide drops. Our code allows that for a punching ratio up to 1.5, if you have a punching ratio up to 1.5, you may also provide you may also provide punching reinforcement for it. So up to a punching ratio of 1.5, you may provide punching reinforcement for it. All right, that is what our code tells us. Which code? IS456. You go to shear in flat slabs. There you will get this. In one of our courses on flat slabs, we have discussed this issue in great detail. So up to punching ratio of 1.5, you are able to provide it. Now, in which, okay, so this is one part. Now, what he's asking, can you please throw some light on flat slab without drops? So, if I have to provide flat slab without drops, called as flat plates, usually, there this punching thing will become even more critical because now you are not even providing a drop. So, in such cases, again the rule remains the same that you can allow a punching ratio of up to 1.5 and provide punching reinforcement for it. If your punching ratio is more than 1.5, then no amount of punching reinforcement will be helpful because the code says you have to increase the thickness of your slab. So either you increase the thickness of your slab or you increase the size of your column. Whatever you do, punching ratio you bring it below 1.5 if you wish to provide punching reinforcement. So the logic is that if punching ratio exceeds 1.5, you have to revise section. So either you revise your slab section or you revise your column size, whatever you want to do, you do. If your punching ratio is less than 1.5, sorry, if your punching ratio is less than 1, that means okay. Whatever slab thickness you are providing, whatever you are doing, it's okay. Punching ratio is less than 1. If your punching ratio is between 1 and 1.5, what are your options? Yes, please tell me. What are your options if your punching ratio is between 1 and 1.5? Tell me. So then you have the option to either revise the section if you wish to do so, or the code allows you to provide punching reinforcement. Do you understand? This is the basic concept. This is the basic concept about the punching reinforcement. Now, how do we provide punching reinforcement? So, punching reinforcement can be provided in different sort of configurations. One of the ways, and I'm not showing you the calculations over here right now, but one of the ways can be that if this is my column in plan and I have a large slab, remember this is without drop, so I can provide vertical links like this in the periphery and arranged like this, and then this type of parallel link system will go till a certain distance. The code says where the punching ratio reduces to zero point 0.5. So where the punching ratio reduces to 0.5, no, what does it say? Where the punching ratio reduces to zero point 0.5 of tau c, not zero point 0.5. So you have to keep on adding these links. You may start from, let's say, d by 2 distance where the punching is critical. You start from there and you have to go on providing these links in plan view till your punching ratio goes below zero point 0.5 tau c. And what is this tau c? It is 0.25 under root fck, two-way punching stress, two-way shear stress. Okay. So this is one of the ways to provide links. And of course, these links are connected to your bars that you have placed in your flat slab. So there will be bars in both directions. So these links usually will be connected to these bars. Got it? This is one of the way of doing it. Other way of providing punching reinforcement can be that you provide a concealed beam sort of a arrangement. What does that mean? If this is my column, I provide a concealed beam sort of an arrangement, but remember that beam has to be wide as d by 2. It has to go up to d by 2 like this. So these are concealed beams. Do you follow what I'm trying to say? So this is a concealed beam type of thing, and it will have these stirrups. So these stirrups are going to take the punching. These stirrups, black stirrups that I'm drawing in plan, these are going to resist the punching shear stress. Understood? So this is the other arrangement that we may provide if we want to provide punching reinforcement. Another arrangement can be to incorporate girders. So if you don't want this arrangement, instead of providing a concealed beam like of a thing, you may incorporate girders inside this, and those girders will be there to take the shear or the punching shear. Okay. So these are some of the options that you have if you have a flat slab system and you want to provide punching reinforcement for it. Okay. So this is a critical issue and you have to deal very carefully about this. So as I said, either you provide links or you provide concealed beams or you provide some embed steel sections. Now you may also, if you don't want to provide a horizontal steel section like this, people also embed it vertically like this. So they will embed sections like this in the depth, along the depth of your flat slab. So all kinds of options are possible if you want to. Uh, if your punching ratio is exceeding 1 but it is less than 1.5, and if you want to provide punching reinforcement, all these options are possible. Okay, is it clear? Okay, so this was what he had asked. This was from Mr. Saif Ahmed. Now next question is from Mr. Farhan Danish. He is joining from Aurangabad, and his question is, let us see what he is asking. So when should one start own consultancy? How much experience should one, what is he saying? Wait a minute. When when should one start own consultancy? How much experience should one need to start own consultancy? I mean, I don't know how much experience is needed. Some you must. I mean, I don't have an answer. There is no rule for this. When you should start, when you should not start, how many years you need. I'm not sure about it. But maybe I would say at least 2 to 3 years. Try and work for someone else before taking the or starting it yourself. You can always first do some apprenticeship or you work somewhere else for at least 2 to 3 years so that you are exposed to a different design situations that may happen or that uh, you may get in a consultancy or a design office. So at least you are able to know that if such situations occur when you are working on your own, then how to deal with them. Okay, if you have a supporting system of someone in your family or someone your senior who may guide you during your work, then you may start early because you have their backing. Okay, so then you may start early also because you know that even if you face certain difficult situations technically or otherwise, they will be there to guide you and resolve those issues. So maybe then you might start after 1 2 years, but I personally I think 2 to 3 years 4 years at least you should spend before you start doing your own work, especially consultancy work, because people are going to come to you for advice. Okay, so just like doctors also, they don't start straight away practicing after their mbbs. They spend a lot of time. In fact, in their coursework also, they spend a lot of time in dealing with practical situations. Then even after their during their post graduation also, they have to spend a lot of time in actual hospital situations, and then they would get associated with a few other senior doctors or hospitals before starting on their own. Similarly, you can also think of it this way that as a consultant, you will be uh, required to take decisions on your own for the project. So it is better if you have a experience of 2 to 3 years. That is my opinion. It's not any rule. My opinion. You may wish to differ. I mean, you may differ with my opinion. That's perfectly fine. Some people are consulting at very less fees in our area. When we charge at clients, they say that they are charging less. Why you are charging more? So then we won't get work. Yeah, see, now for this, I don't have any answer because it is all market dynamics. So someone is charging less, he or she is getting the work. I mean, I don't have much to say about it. It is the market dynamics. It is between you, the client, and how much they are willing to pay, how much you are willing to, for how much amount you are willing to work for. So these are all market dynamics. I don't have to say anything about it. Okay. Yes. So I guess this time we have only these many questions. So now if someone has any question, they may ask on the YouTube live. I mean that is they can put a question in their comment. Uh, we have finished today's questions that were asked in the Google form. There was no question asked through email. So I guess if you any one of you wants to ask anything. Oh, Mr. Tosh has mailed one more question. Very good. Let me see. In the meantime, people in the YouTube, if they want to ask, you can put comments and we'll take those questions. If someone wants to join the live session, they may tell me. I'll send the link. If someone wants to join this live session, and ask. Okay, so Mr. Tosh had one question that he had asked. No, this I had taken. Acha, ha, correct. This is his question that he has asked. So, Mr. Tosh is asking, he's from Raipur, he's a working professional. Uh, let's see what he's asking. When we have inclined flange in PEB, he's saying when we have inclined flange in PEB, then for connection with rafter, we need to make it straight. Then we do full penetration butt weld between those column flanges. No, so here I was trying to tell you that day that suppose you have a column cross section like this, okay, and for some reason, whatever you have made it tapered. So I think this is what you're saying, column cross section. And what you are saying that this is your flange. Wait a minute. So this is my rafter, let's say. I think what he is trying to ask is that if I provide an extended end plate type of connection, he is thinking to replace the column flange with the extended end plate. And then his question was that over here also I will have some column flange. So I go for a butt welding. That was his question. Okay. So what you need to first understand that we don't do such a thing. I mean, basic thing will not be like this. First of all, you provide a full column flange. So your column flange will be full. Okay. Here, additionally, you will have to provide an extended end plate, and to this extended end plate, your beam is connected, and then you will have your stiffener assembly, whatever, and then you will have your bolt assembly, whatever you are providing. So first thing, please understand that it will not be an abrupt situation like this, where you will provide this type of an assembly that this is my end plate and there is no column flange. No, this has to be first. There has to be a column flange over here. To that column flange, then an additional end plate will be bolted by the use of extended end plate connection, and of course the beam is welded to this end plate. Okay. Okay, so his question was not this. His question is column flange will be bent. No, no, why will column flange be bent? You will make your web like this. So this will be one part of the web where this web is sort of tapered. This web is another web, and flanges are straight. Why do you think flange will be bent? There are these two. You see, this is my web. So this becomes my web, first piece of web, let's say. Then I cut a web like this triangle, and I join it. This is my second web. And flanges are flanges. These are getting connected like this. What is the problem? This is my flange. This is my another flange. This is my another flange. All of them are getting fillet welded to the web. So there is no bent flange. Then this is my fourth piece of flange. So overall, this might be one flange over here, one plate. This will be another plate. This will be another plate, flange plate. The flange plate 2 and flange plate 3 will be fillet welded to the webs. And plus at this joint, you can provide either you can provide a butt welding, okay, full penetration butt weld, or you can just provide a half penetration butt welding, or some people will add a, an extra plate over here at the underside and provide a fillet welding. Whatever you want to do, you are it's possible to do. Okay, understand, but column flange is not required to be bent. We are making it in different pieces. How do you make a tapered section PV? So very simple. If you want to, Let's say in a beam, if I want to make this type of a beam in a PEB, okay, this is the front elevation. How do I make it? Very easy. I will have this flange plate. I can have this web. Either I can cut my web like this. Remember, this is the front elevation. So my beam is a tapered, having a depth D1 at the start, D2 at the mid span. So either I make a web like this, I cut my web in elevation like this, and then I will just attach my flanges over here. Okay, fillet weld my flanges. This is one way. I hope you are understanding. Or the other way can be that I make this web into two parts. So this sort of trapezoid shape becomes my first part of the web. This becomes my second part, and these are my flanges. Again, I fillet weld my flanges. Okay, and then now regarding this one and two, there are options. I may go for a butt weld. Some people like to add some additional splicing plates over here, and they will provide a fillet weld over here. Okay, similarly for flanges also, some people like to add splice plates over here. They will like to fillet weld it, or if you have the option of butt welding, you can do butt welding also. Okay, so with these new technologies, it is possible for you to do a good butt welding and get good strengths for them. All right. Yeah. Okay. Yes. So anything else? We have answered all the questions that were asked on email and that were put in the Google form. So anything else, or we close our session for today? Yes, please. Anyone wants to ask anything or share anything? Any comments? We have time. Okay, so I think there are no further comments, no further questions. So I'll wait for a couple of minutes and then we can close this session. Mr. Tosh is saying stitch slab. I don't know what stitch slab means. I don't know stitch slab. Anyone who knows stitch slab? I do not know about it. To prevent uplift of basement slab. Okay, okay. So I think what he's saying is that suppose I have this situation. Let's say this is my basement wall. I'm trying to draw a cross section, and these are my internal columns. And internal columns have been provided footing at a lower depth. Okay, and again on this side I have my basement wall. So I guess this question is that if we provide a slab over here, and this entire thing has been drawn tilted. I don't know why. Okay, so this I think his question is that if there's a water table over here, so there are chances that because of this uplift, if this slab is not properly done, it may just fail under that uplift pressure. And I have personally seen projects where this slab has failed and it has sort of given away, and then the underground water just fills up the whole basement. I have seen that sort of a thing happening. So I guess he is calling this as a stitch slab, is it? So you have to design this slab for the uplift pressure, for the water upthrust that is expected due to rise in water table or due to presence of water table. So you have to integrally connect this slab with your columns. So it cannot be a floating slab or it cannot be like a slab on grade. You have to integrally connect it, and remember that the moment distribution in this slab will be just the reverse of what you would get in a normal suspended slab. Okay, because of the uplift pressure, you may have to provide reinforcement like this at the midspan, reinforcement at top, and at column positions, reinforcement at bottom. So this type of reinforcement may be required in this type of slab. Now, what Mr. Tosh is saying, that in some cases we may have the possibility of anchoring it down. Is that what you're saying? We may have a possibility of anchoring it to the strata below. Is that what you're saying? So that will depend on the type of strata that you have. Now, if you have a rocky strata, you may use some bolt-like arrangement or even reinforcement, which you can sort of drill into the hard strata, and that reinforcement then can be developed in the slab. You can do that type of a work. But if you have a soft soil and if this type of anchoring is not possible, we have done a couple of at couple of places. We had actually used piles, underream piles, and those piles, the reinforcement of those piles, we had developed it into our slab. So pile can take up thrust, and that reinforcement will help you to hold this slab together. So maybe if you don't have a hard strata and if anchoring is not possible, maybe you can do some underreaming pile sort of a thing. If again pile is possible, then you can do it. If none of these are possible, then you will have to design your slab for the full upthrust load and ensure that it has adequate thickness and adequate reinforcement provided. Okay, right. Okay. Anything else? Okay. So I think this is all for this week then, if there are no more questions. So next week we meet you again, next weekend that is, and you can put your questions in the Google form or you can send it through email. Just write ask AuxEn anything in the email subject and send it to us. So next weekend, same time, we'll take further queries that you might have. So that's all then. Thank you. Bye bye. Now we'll see you next week. Weekend that is. Okay, bye.